Hi everyone, I'm William.
I'm Giacomo.
Hi Matteo.
And I'm going to present our project, Home SecuriPi. The problem we are trying to address is related to home burglaries. More in details, we would like to develop something that is able to detect movements and sound inside the house. Anyone who owns a house and would improve its security might want this, because they would like to feel their home protected, especially when they are not at home. It is a very cheap solution, reliable enough since it doesn't crash, it avoids false positive and also sends alarm messages in less than 5 seconds. And to conclude, it is also easy to blend thanks to its black container. Canary camera is another solution available on the market, and we think our solution is better since this product is quite expensive, so it doesn't meet our cost requirements. And while it has some interesting features like, for example, live camera or past recordings, it doesn't provide neither movements detection nor alarm notification, which are implemented in our system.
Now I will talk about the hardware. The first thing that we did was go into the lab inside Reykjavík University, and they were kind enough to give us a complete starter pack of Raspberry Pi, which also contained a camera, a PIR sensor, a speaker, and a microphone. All these components put together would cost a total of $34.79, which is the current price. Of course, it may fluctuate over time, but that's the usual cost of the entire hardware. And so it is easily noticeable that it's very low if compared to the commercial solutions. The software is the most important part of our project, probably. It is composed of 4 Python scripts. We use Python to develop this system. And the first script, the most important, is the core, which is the heart of the program, and it manages the Telegram bot. It controls the speaker, which is the main output of our project. And it is also used to enable and disable the other scripts, which are the 3 others that I listed in the slide. And by doing this, it can turn on and off some features in order to save battery. The camera is used to detect human movements. The mic is used to detect loud noises, for example, a window shuttering or something like that. And the PIR is used to detect presences and communicate, and also communicate it to the core, which is what every one of them does. This is the model we developed for the software and for the entire system. The one on the left is the model of the external container, which we printed in 3D using a 3D printer which Reykjavík University gave us. We modeled it using OpenSCAD and then printed it using black plastic, as we will show later. The picture on the right instead is just the schematic of the circuit, which may be useful if anyone else wants to continue with our project, wants to improve it, or just simply replicate it. This is the final design. As I said before, it's a black box containing all the sensors and the Raspberry Pi inside. We decided to choose black as a color because it merged more with the environment, which is a requirement we described at the beginning. And also we calculated all the measures of the box in order to fit all the components inside and also to leave a little bit of space. The current capabilities that the project has are to detect movements up to 50 meters, and it gives no false positive, which is a very common thing to have if detecting movements with a camera. The sound detection is just set to ignore values under the threshold of 58 decibel. It can scare off burglars using the speakers. It sends notification to a single person or a group via Telegram, and that is very interesting because usually the other systems send message just to a single person. Instead, in this case, we can have a group since we are sending notification using a Telegram bot. And also the dark design, as I said before, it's useful because it allows the project to blend with the environment.
Okay, now we'll see some feature extension which could be implemented in this project. First of all, using a powerful Raspberry Pi, for example, a Raspberry Pi 3 or maybe 4, we could have better performance for a more stable system. And then a dedicated app which is able to control it with arm and disarm the system and so on. In this application, we could include a live video of the camera, and in some situations, like during movements detection, the photo capture. Another feature extension is the integration with some skills for example, Amazon Alexa or similar. For instance, when the user is going out, could tell, hey Alexa, turn on home SecuriPi. Last but not least, a light sensor that check if the lights are on or off. To sum up, we crafted and developed this home security system that is able to detect movements and sounds and inform the owner if something happens. This project is a prototype because maybe we need to test it more and more to make it better, but honestly we use a lot of time despite we didn't have it. We would like to thank Reykjavík University and Paciaroni University, which have given us the possibility and the instrumental to develop this useful home security system. To be honest, I believe that it was so engaging.
Did you think about adding a LED to check if the device was operational or not? Okay, thank you. Very interesting question. Actually, we thought about it, but we thought that it would be even better to have our system like completely blended inside a room or inside a building. That's because by blending the home SecuriPi, we could have an improved degree of security and thus like eventual burglars could not see it at first sight or could not see at all during night since it's black. And also the Telegram bot has the same feature, which is the command /status, and which indicates if the system is on or off. So the LED was an interesting feature to add, but we just thought that it was better to make it secure instead of beautiful.
Why did you use Python to develop your program instead using Rust? Okay, nice question. We prefer to use Python over Rust for different reasons. First of all, we thought it was easier to find out information on Python than on Rust. Secondly, having more experience with Python, we decided to use this as we knew that every time we run into some errors, some problems, it will take less time to fix it. And finally, Python has many libraries to work on photos and with camera, so we thought it was the best solution for our project.
Do you think that this is possible to use the camera not only for the movements but for the face recognition? Okay, it's a cool question. It's possible, but it will require a more powerful device. Raspberry Pi Zeros are very slow devices due to their being very small and consuming a low amount of electricity. So it exchanges its cheap CPU as a little power and can be executed only simple tasks. Since recognizing people faces require machine learning, this can be classified as a very complex task and thus cannot be handled by a Raspberry Pi Zero. By using a better Raspberry Pi, for example, the Raspberry Pi 4, as I said before, we have more chance of being able to accomplish this. So we will try to use one of them instead. Another approach could be to upload the camera photos regularly to a dedicated server which just has the role to execute the heavy task and give back the result to the Raspberry Pi, but this still needs to have a very fast network, which currently we don't have.
Do you think that by the info you gave in the presentation and also in the GitHub links, a person without any experience or with a low level of experience in computer science and in mechatronics could maybe manage to reproduce the project as you did it or in a similar way? Okay, cool question. I like that guy actually. Anyway, we could say that the project is probably for anyone, could be done by anyone, since the very difficult parts are coding in Python. So that is directly downloadable from GitHub, so that is done. And also designing the box is also done, and the project can still be downloaded from GitHub. So that are the most difficult parts. And there is actually another part, which is the automatic login for the Raspberry Pi. This is useful because if we want the system to start automatically when we plug in the Raspberry Pi, we have to set the automatic login in the Raspberry Pi itself and the Python code to auto start. That is again quite tricky, but it's still doable, and there are guides online. So if that is if the user manages to do that, then he's done. Okay, I think that was everything. If there are no more questions, this is what we did with the project, and we hope that you liked it and that it was interesting and that you will use it in your own homes. And yes, bye. Thank you very much for your attention.